So let's work another example of a related rate problem. This one is going to be some sort of cone that's actually getting filled up, but there's a lot of different variations of this type of question. So this question reads, the water runs into a conical tank at a rate of 9 cubic feet per minute. The tank stands point down and has a height of 10 feet and a radius of 5 feet. How fast is the water rising when the water level is 6 feet deep? All right. So let's just kind of look at how to draw this and what information we're given. So I have a conical. There's the bell. I know my radius is 5. I know my height here is 10. So my radius here is 5. And your height is 10. And we're pouring water into it at a rate of 9 cubic feet per minute. So this is actually a dV/dt, and I'm writing over the problem. And I know that somewhere in here, the water, this part, this is going to be, what does it say? 6 feet deep. Okay, so we need to know how fast, let's call this part right here an H. We need to know how fast dH dt is going up. All right, so what we have dV/dt. That is at 9 cubic feet per minute. We know that the radius is 5 of the actual cone. We know the entire height of the cone is 10. And then we know this other, I'll call it H sub 1, is going to be 6. So that's all the information we have. That's all the information we really need to figure out how fast the water is rising when it is 6 feet high in the cone. So let's take a look on how to do this. All right, so let's take a look here. With this problem, we're still looking for dH dt. We're looking for how fast is it changing, the height changing with respect to time. There's a little sneaky thing in here. There are similar triangles right here and right here. So I'm going to set up a ratio so I can kind of figure out really what's going on. And I want to end up, whenever you see similar triangles, you're going to set up these ratios to help you solve the problem. All right. So I see that I'm going to have a radius on the big one of 5 over r for this generic height, for the generic height of h. And I'm going to have an overall height of 10 for a generic height of 8. Well, I can cross multiply these. I get 5h equals 10r. Therefore, we know h equals 2r by simplifying. All right. So this is going to be key as we solve this problem. That's going to be key. So we need to find the change of height over time, but I know I got to change of volume over time. So I've got to think, all right, what's the formula that's going to relate volume to radius and to height? Well, that's just our volume formula. Our volume is 1/3 big B H. Okay. So let's think. 1/3 big B H. Well, I know my big B, so let's do this. Volume is 1/3. My big B is a circle, so that's going to be pi r squared h. Well, I've got 3 variables here. I only need a v and an h. I need to get rid of this r, only if I had a way to do that. But I do, because I can rearrange this and say that my r is going to be 1/2 of h. Just by rearranging it, now I can substitute in. And I can say my volume is going to be 1/3 pi times 1/2 h squared h. And I can simplify this down to get my volume equals 1/3 pi 1/4 h squared h. Gives me a volume of 1 or pi over 12 h cubed. All right, so now I have a volume formula that is nice and generic that's going to be set up off of this ratio. So I can take the derivative of this. I get dv dt equals, well, if I bring my 3 down, this is going to become pi over 4 h squared dht. All right. So it seems like I'm missing something. I need to know what h is. Oh, yeah. Told me it's when it's 6. So I have an 8. So, and I have a dv dt. So I have 9 equals, well, 6 squared is 36. 36 divided by 4 is 9 pi dh dt. When I divide this over, I'm going to get dh dt equals 1 over pi. And this is going to be, so for my height, once I do all of my units worked out, that being in feet per minute, this is going to be approximately 0.318 feet per minute. So the key is, when you're getting similar triangles, you need to set up your proportion like this, so you get a statement like this, because 9 times out of 10, in fact, every time I've had to set up similar triangles, I've had to use this statement right there. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.